One of the biggest misunderstandings in education is that an expert just knows more than a novice. However, that is not the biggest difference. In this video, we will use cognitive load theory to look at the actual difference, and you will see strategies that you can use to become an expert faster. So stay tuned to see how to learn more using cognitive load theory. Let's begin with the multi-store model of memory. We start with sensory memory. Our senses are bombarded with about 10 million bits of information every second. However, our brains can only process about 40 to 50 bits per second. So, your brain filters out most of that information. Only the parts that are paid attention to make it to working memory. Working memory is where we consciously process information. It is characterized as having a small capacity and a very short duration. Wait! You may be thinking, I can keep something in working memory for a long time by just repeating it over and over. You're right! By rehearsal or other forms of maintenance, we can keep items in working memory for longer. You've probably done this with a phone number. You recite the number 555-3141, 555-3141, until you get it into your phone. But then it is gone. To learn, we cannot just have information running around working memory. We need it to make it to long-term memory. Long-term memory is characterized as having a huge capacity and potentially a lifetime duration. Learning means a change in long-term memory. So, how do we do that? Through the deep processing of information in working memory. Let me stress that again. We need to deeply process information in working memory to get it into long-term memory. I have seen so many students study for hours and hours, but learn little. Information is running around their working memory. They output lots of correct answers during this practice, but they are only outputting answers. By not processing the information deeply enough, little makes it to long-term memory. Of course, we also want to ensure that we are storing information in long-term memory in a way that makes it easier to retrieve later. Let's look at this again using my favorite analogy. I think of the multi-store model of memory as my office. First, sensory memory is like my office door. It only lets in the information that I pay attention to. Working memory is like my office desk. It is too small. And long-term memory is like my filing cabinet. In the filing cabinet, there are lots of file folders called schemas. A schema is a collection of information or knowledge stored in long-term memory. A schema can contain only a tiny bit of information on a very specific topic, or it can contain a massive amount of information on a very broad topic. However, and this is the key point, no matter how big or how small the schema is, it takes up only one of the 4 working memory slots. Let's go back to the office analogy to see the role that schemas play. This will also show us the difference between an expert's brain and a novice's brain. Starting with an expert's brain, say they receive a problem through sensory memory. The problem will take up one of the 4 working memory slots. Now, the brain starts looking through its filing cabinet for what matches the pattern of the problem the best. In the expert's brain, this is a massive folder. The folder is dropped into another one of the memory slots. This folder contains all the information needed to solve the problem, including facts, procedures, and problem-solving methods. Since this massive folder only takes up one slot, there is still lots of room on the desk for the brain to work on solving the actual problem. But even more importantly, there is still available space to deeply process the information. That is, the brain can incorporate the new information into the existing schema. That is, there is still mental resources available to devote to learning. Okay, now let's contrast that with a novice's brain. Say the novice gets the same problem in through sensory memory. Once again, their brain will try to find the best match. In the novice's brain, they are just able to pull out a thin folder based on the surface features of the problem. Using the information in that folder, they can start pulling out other folders that contain information that might be helpful to solving the problem. But now they have no working memory resources left to actually solve the problem, let alone to actually learn anything. Now, the brain does have some strategies. For example, it can shove one of the folders to the floor to free up some space. All those times where you made a silly mistake or suddenly couldn't remember a fact that you knew, this is what happened. You had cognitive overload. Throw your best brain freeze moment into the comments below. So, the main difference between an expert's brain and a novice's brain is that the expert has collected and connected all of the information together. When they are solving a problem, they have all that they need at their fingertips. On the other hand, even if the novice has learned all the concepts, their brain sees them as isolated facts. So, due to cognitive overload, they have difficulty using all of the information together. This difference has been demonstrated in many studies. For example, in one study, novices and experts were asked to classify physics problems. Novices categorized them by the surface features. That is, they just had a small folder for these specific kinds of problems. On the other hand, experts categorized them by physics principles. That is, they had one huge physics folder, so they could look at the big picture. In conclusion, cognitive load theory says that you can become an expert faster by, number one, always trying to incorporate new information into your existing knowledge. Try to think about the big picture and try to form one large schema rather than separate small ones. And number two, by having all of the necessary facts well memorized. Having to look up information not only takes time, but it takes some of your valuable working memory resources. I hope you have enjoyed this video and find these strategies as effective as I do. To learn more, see these other informative videos. Thanks for watching!